Hi dear children, welcome to today's class. Today we are going to continue exercise 11.2, 10th question. Find the angle between the following pairs of lines. First one, r vector is equal to 2i minus 5j plus k plus lambda into 3i plus 2j plus 6k, and r vector is equal to 7i minus 6k plus mu into I plus 2j plus 2k. So the equation of lines that is given, and we need to find out the angle between these two lines. So the first one, that is in the form a vector plus lambda b1 vector, and the second one, that is in the form a2 vector plus mu b2 vector. And if the vector equation of two lines is given, then the cos theta is b1 vector dot b2 vector divided by magnitude of b1 vector into magnitude of b2 vector. So in this question, that b1 vector is the vector with lambda. Okay, so we will get b1 vector is equal to 3i plus 2j plus 6k, 3i plus 2j plus 6k, and b2 vector, that is the vector with mu, or that is the vector in second line. Okay, so that is I plus 2j plus 2k, I plus 2j plus 2k. Now we need to find out the angle, that is cos theta is equal to b1 vector dot b2 vector divided by magnitude of b1 vector into magnitude of b2 vector. Okay, so we are going to find out this b1 vector dot b2 vector, because in this equation we need b1 vector dot b2 vector and magnitude of b1 vector, magnitude of b2 vector that we need. So we are going to find out b1 vector dot b2 vector first. So b1 vector dot b2 vector is equal to 3i plus 2j plus 6k dot I plus 2j plus 2k, I plus 2j plus 2k. Okay, this is our b1 vector dot b2 vector, and these vectors are given in component form. So that dot product is I component into I component, that is 3 into 1, that is 3, plus j component into j component, that is 2 into 2, 2 into 2 we will get it as 4, plus k component into k component, that is 6 into 2, 12 we will get. So this is equal to 3 plus 4, 7, 7 plus 12, that is 19. So b1 vector dot b2 vector we got it as 19. Now magnitude of b1 vector, that is equal to square root of I component square 3 square plus j component square plus k component square, I component square plus j component square plus k component square, that is equal to square root of 9 plus 4 plus 36. This is equal to square root 49 is equal to 7. Square root 49, that is equal to 7. And this magnitude of b2 vector is equal to square root of I component square, that is 1 square, we will get it as 1, and j component square, that is 2 square, that is 4, plus k component square, k component 2, and the square is 4. This is equal to square root 9 is equal to 3. So we got the value of b1 dot b2, magnitude of b1 vector, magnitude of b2 vector. Now cos theta is equal to b1 vector dot b2 vector divided by magnitude of b1 vector into magnitude of b2 vector, and this is equal to b1 vector dot b2 vector, the value is 19, divided by magnitude of b1 vector 7 into 3 is equal to 19 by 21. So this is the angle between given two lines. Now we are going to do the 11th question. Find the angle between the following pair of lines. First one, x minus 2 by 2, y minus 1 by 5, z plus 1 by minus 3, and x plus 2 by minus 1, y minus 4 by 8, z minus 5 by 4. The difference between the 10th question and 11th question, 10th question vector equation of the line is given, and in 11th question Cartesian equation of the line is given. Okay, so 11th question, the given equation is x minus 2 by 2 is equal to y minus 1 by 5 is equal to z plus 3 by minus 3. And the second one is x plus 2 by minus 1 is equal to y minus 4 by 8 is equal to z minus 5 by 4. Okay, this is the equation of two lines in Cartesian form. So just compare it with the first one with this x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. This is the general form of equation of a line in Cartesian form. So just compare it with, then the first one is x minus 2. So that is of the form x minus x1. The denominator, that is the value of a is 2. And here the value of b is 1. And here thus we can write it as z minus minus 3, then this is of the form z minus z1 divided by c. So the value of c is minus 3. So since we have two lines, I am going to take the first one. a1 is equal to 2, b1 is equal to 5, and c1 is equal to minus 3. c1 is equal to minus 3. Now second one. Okay, the coefficient of x here it is 1, coefficient of y 1, coefficient of z 1, and this x plus 2 we can write it as x minus 2. X plus 2 we can write it as x minus 2. X minus 2 divided by minus 1. Okay, x plus 2 is x minus 2 divided by minus 1. So this is of the form x minus x1. Okay, the value of x1 is minus 2. And y minus y1 form, z minus z1 form. So no problem. Just write the denominator. Then we will get a2 is equal to minus 1, b2 is equal to 8, and c2 is equal to 4. a2 equal to minus 1, b2 equal to 8, and c2 equal to 4. So we got the value of a1, a2, b1, b2, and c1, c2. Actually this a1, b1, c1, that is the denominator of the first equation, and a2, b2, c2, that is the denominator of the second equation. If it is in the form of x minus x1, y minus y1, z minus z1, if that numerator in that form, then just write the denominator. We will get the values of a1, a2, b1, b2, and c1, c2. Now cos theta is equal to, okay, so you can either use this formula, cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 divided by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. Or you can write this equation into vector form and you can use this formula. Anyway, I am going to use this formula. Then cos theta is equal to, cos theta is equal to, our formula is a1 a2 plus b1 b2 plus c1 c2 all divided by a1 a2 plus b1 b2 plus c1 c2 all divided by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. This is our formula. Cos theta is equal to, cos theta is equal to a1 square plus b1 square plus c1 square denominator, a2 square plus square root of a2 square plus b2 square plus c2 square we will have in denominator. Now just substitute the values. Okay, we have all that values and just substitute it. We will get it as, this is equal to 2 into minus 1 plus 5 into 8 plus minus 3 into 4 divided by square root of 2 square plus 5 square plus minus 3 square into square root of minus 1 square plus 8 square plus 4 square. Okay, 2 into minus 1 plus 5 into 8 plus minus 3 into 4 divided by square root of 2 square plus 5 square plus minus 3 all square into square root of minus 1 square plus 8 square plus 4 square. And this is equal to 2 into minus 1 minus 2 plus 5 into 8 40 minus 12 divided by square root of 4 plus 25 plus 9 into square root of 1 plus 64 plus 60, and that is equal to 26 divided by square root 38 into square root 81. Square root 38 into square root 81. Okay, this is the value of cos theta. Okay, so cos theta is equal to 26 divided by square root 38 into square root 81. We need to find out the angle between. That means we need to find out the theta. Theta is equal to cos inverse of, just take this cos into RHS, cos inverse of 26 divided by square root 38 into square root 81. 26 divided by square root 38 into square root 81. Now, the 12th question. Find the values of p so that the lines 1 minus x by 3 is equal to 7y minus 14 is divided by 2p is equal to z minus 3 by 2 and 7 minus 7x by 3p is equal to y minus 5 by 1 is equal to 6 minus z by 5 are at right angles. Right angles means the value of theta is given. Okay, the value of theta is 90 degree. Value of theta is 90 degree. That means these two lines are perpendicular. Yeah, these two lines are perpendicular. So, consider the given equations. The first equation is 1 minus x by 3 is equal to 7y minus 14 divided by 2p is equal to z minus 3 divided by 2. Okay, if your equation is given in Cartesian form, you need to convert that equation into this form. X minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Okay, just look at this. This is not in the form x minus x1. We need to make it as x minus x1. That means here the coefficient of x is minus 1. We need to make it as 1. For that, just multiply numerator and denominator by minus 1. Okay, just multiply numerator and denominator by minus 1. So, minus of 1 minus x divided by minus 3 we will get. And what is this minus of 1 minus x? That is x minus 1 divided by minus 3. Okay, now this is of the form x minus x1 by a is equal to, here the coefficient of y is 7. But we need to get the coefficient of y as 1. Y minus y1 by b. Okay, that is our equation, y minus y1 by b. So, if you want to make the coefficient of y as 7, just divide numerator and denominator by 7. Okay, just divide numerator and denominator by 7. That is 7y minus 14 divided by 7 divided by 2p by 7. Okay, this we will get it as 7y by 7. That is y minus 14 by 7, 2 divided by 2p by 7. Okay. And third one, no problem. That is in the form z minus z1 by c. Z minus 3 by 2. Okay. Now, just compare it with our general form. X minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. That is our general form. And this is in that form. So, the denominators will give, since we have two lines, I am going to take it as a1 is equal to minus 3, b1 is equal to 2p by 7 and c1 is equal to 2. Okay, a1 is equal to minus 3, b1 is equal to 2p by 7 and c1 is equal to 2. Now, consider the second equation. The second equation is 7 minus 7x by 3p is equal to y minus 5 by 1 is equal to 6 minus z by 5. 6 minus z by 5. Okay. This is also in Cartesian form. So, we need to make it into that form. X minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. We need to convert that into that form. So, here the coefficient of x is minus 7. Coefficient of x is minus 7. So what we are going to do is, we are going to divide. We need to make that coefficient into plus 1. X minus. Okay, we need to make it into plus 1. So just divide numerator and denominator by minus 7. 3p divided by minus 7 is equal to, second one, no problem, no need to make changes, is equal to, and third one, the coefficient is minus 1. We need to make it into 1. Okay, so just divide numerator and denominator by minus 1 divided by 5 by minus 1. Okay, this is equal to 7 by minus 1, minus 7. 7 by minus 7, that is become minus 1. And this is become minus 7 by minus 7, that is plus 1. So we will get it as x, and 7 by minus 7 minus 1 divided by 3p divided by minus 7. 3p divided by minus 7, or we can write it as minus 3p by 7. 3p divided by minus 7, we can write it as minus 3p by 7. And this is equal to y minus 5 divided by 1 is equal to, and this is minus 1 by, is minus z by minus 1, that is plus z. 6 by minus 1, that is minus 6, divided by 5 by minus 1, that is minus 5. Now this is in the form x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. So take a2 is equal to minus 3p by 7, b2 is equal to 1, and c2 is equal to minus 5. So we got that a1, b1, c1, a2, b2, c2. And it is given that the angle between these two lines, that is 90 degree. That means these two lines are perpendicular. These two lines are perpendicular. And we know that if two lines are perpendicular with the direction ratios a1, b1, c1 and a2, b2, c2, then a1, a2 plus b1, b2 plus c1, c2 is equal to 0. If two lines are perpendicular with the direction ratios a1, b1, c1 and a2, b2, c2, then a1, a2 plus b1, b2 plus c1, c2 is equal to 0. That is minus 3 into minus 3p by 7 plus 2p by 7 into 1 plus 2 into minus 5 is equal to 0. This is minus 3 into minus 3, that is 9p by 7 plus 2p by 7 minus 10 is equal to 0. Actually, we need to find out the value of p. 2p plus the denominator is 7, so we can add the numerator. 9p plus 2p, that is 11p by 7 is equal to 10. So 11p is equal to 70. P is equal to 70 by 11. So the value of p, that is equal to 70 by 11. 13th question. Show that the lines x minus 5 by 7 is equal to y plus 2 by minus 5 is equal to z by 1 and x by 1 is equal to y by 2 is equal to z by 3 are perpendicular to each other. We need to prove the given two lines are perpendicular to each other. Perpendicular means we need to prove this a1, a2 plus b1, b2 plus c1, c2 is equal to 0. So the given lines, that is x minus 5 by 7 is equal to y plus 2 by minus 5 is equal to z by 1. Okay, this is our first equation and it is in this general form, x minus x1 by, the coefficient of x is 1, coefficient of y is 1 and the coefficient of z is 1. So no problem. From this we will get a1 is equal to 7, b1 is equal to minus 5 and c1 is equal to 1. a1 is equal to 7, b1 is equal to minus 5, c1 is equal to 1. And the second equation is x by 1 is equal to y by 2 is equal to z by 3. This is our second equation. And here also the coefficient of x, y is z, that is 1. So a2 is equal to 1, b2 is equal to 2 and c2 is equal to 3. a2 is equal to 1, B2 is equal to 2 and C2 is equal to 3. And we need to prove these two lines are perpendicular. For that we are going to consider A1 A2 plus B1 B2 plus C1 C2. A1 A2 plus B1 B2 plus C1 C2, and this is equal to A1 A2. A1 is 7. 7 into 1 plus minus 5 into 2 plus 1 into 3. That is 7 minus 10 plus 3 is equal to 0. So we got A1 A2 plus B1 B2 plus C1 C2 is equal to 0. That means the given lines are perpendicular to each other. That means the given lines are perpendicular to each other.